Hello everyone. In this module, we are going to learn about the advanced 3D plots and following are the topics that we are going to cover. Firstly, we will learn what is surface plot. After that, we will learn wireframe plot and in last, we will learn about the contour plot. So, in the previous module, we have learned about the 3D basics plot. So now we will learn about the advanced 3D plots and the first advanced 3D plot is surface plot. So the surface plot depicts a functional relationship between two independent variables called x and z and the specified dependent variable called y. And this plot is also a companion plot to the contour plot. So the syntax to create this plot is axis dot plot underscore surface and in parentheses we pass three different arguments x, y and z. As we are working on the 3D plots, it is necessary to have three coordinates. So now we will discuss some application of this surface plot. The 3D surface plot is used in regression analysis and it is also used to check the multiple regression predicts that if the surface is flat, is this assumption is appropriate or not. So now we will learn how to create the surface plot. The first step is a two-dimensional grid of an independent variable x and z are constructed and the range of this grid is equal to the range of the data. The next step is we have to calculate the dependent value y for each grid point and this y value is defined as a weighted average of all data values near the grid point. And the last step is we use these average value and construct the 3D surface plot. So now we will see an example where we learn to create this 3D surface plot in Matplotlib. So here is the code. Firstly, I import the necessary libraries. The first one is matplotlib.pyplot as plt. The next one is numpy as np. After that, I define small x and small y data coordinate using the arrange function of a numpy module. Then we use the match grid function that generates a rectangular grid from 1D array x and y donating a matrix. So we compute match grid value and assign capital X and Y variable to it. Next, I define the Z data coordinate using a sine function plus cos function. So I pass capital X as an angle to sine and capital Y as an angle to cos. Then I create a figure. For this I call the figure function and I also pass fig size parameter to it as I want to change the size of the figure. So I pass it as 10 inches and 6 inches where the 10 inches represent the width and the 6 inches represent the height of the figure and I assign fig variable to it. After that I create a axis. For this I call the axis function and I pass keyword argument projection to it and set its value to 3D as we want to create a 3D plot and I assign AX variable to it. Then I call the plot underscore surface function as I want to create the surface plot and I pass capital X and Y and capital Z as a argument to it as we want to create a 3D plot regarding these data coordinates and I call the plot underscore surface with respect to AX variable and I also pass additional parameter cmap and set its value to set3 and I assign s variable to it. Then I want to add a color bar to this figure. For this reason I call the color bar function and I call this function with respect to fig variable and I pass s value as a mappable object. Then I call the show function as I want to display the plot. So now I execute this code and here is the output. You can see that it creates a surface plot with x, y, z axis and it also creates the color bar along with this plot and it shows that which color represent the which scalar value. So now we will learn to create the wireframe plot. So The wireframe plot takes a grid of values and distributes it on the specified three-dimensional surface and can make the resulting 3D dimensional form quite easy to visualize. And the syntax to create this wireframe plot is axis dot plot underscore wireframe, and we have to pass three argument x, y, z, as we are going to create this plot as a three-dimensional. For this reason, we need the three data coordinates. So now we will see an example to learn how we create the wireframe plot. So here is the code where we learn to create the wireframe plot. So firstly, I import the necessary libraries. The first one is matplotlib.pyplot.splt, as this library is necessary for data visualization, and the next one is numpy as np, as it is necessary for data definition. Then I define data coordinates. For this I use line space function of a numpy module, and I assign small x in the small y variable to it. Then we use the mash grid function that generate a rectangular grid from the two 1D arrays which I defined above, small x and small y, and I assign capital X and Y variable to this. After that, I define z data coordinate, which is x raised to power 2 plus y raised to power 2. So with this we compute the value of a z. Then I create a figure. For that reason I call the figure method, and I also want to change the size of the figure. For this I pass the keyword argument fig to this figure method, and I set its value to 12 inches and 7 inches, where 12 inches represent the width and the 7 inches represent the height of the plot, and I assign fig variable to it. After that I want to create the axis. For this reason I call the axis function, and I pass projection keyword argument to it and set its value to 3D, as we want to plot the 3D graph, and I assign ax variable to it. Then I want to create a wireframe plot. For that reason I call the plot underscore wireframe function with respect to ax, and I pass capital X, capital Y, and capital Z as a data coordinates to it, and I also change the color of the wires to red. For this reason I pass the keyword argument color and set its value to red. And in last I call the show function, as I want to display this graph. So now I execute this code, and here you can see that it creates a plot with wires. It has a shape like a net. So we can say that it looks like a wire frame. So it has three axes, x, y, and z, as we are working with 3D plots. So now we will learn to create the counter plot. In a 3D contour plot, all input data must be in the form of two-dimensional regular grids, with the z data being evaluated at each point. And the syntax to create this graph is axis.contour3d, and in parentheses we pass three keyword arguments x, y, and z, which represent the data coordinates. So now we will see an example to construct a counter plot. So here is the code where we will learn to create the counter 3D plot. For this I again import the necessary libraries Matplotlib and NumPy. After that I define the data coordinate. For this I call the line space function of the NumPy module, and I assign small x in the small y variable to it. After that I want to compute the mash grid value, which generates a rectangular grid from two 1D arrays which I defined above as small x and small y, and I assign capital variable x and y to it. Then I compute z coordinate. For this I call the cos function and the sine function of the numpy module, and z is computed as cos with angle x multiplied with sine with angle y, where angles are represented with capital X and capital Y, not with the small x and small y. Then I want to create a figure. For this reason I call the figure function, and I set its figure size to 12 inches as a width and 9 inches as a height. Then I call the axis function as I want to create the 3D plot. For this I call the axis function and I pass keyword argument projection to it and set its value to 3D, and I assign a variable ax dot to it. After that I want to create the 3D plot. For this I call the contour 3D function and I call this function with reference to ax variable which I defined above. And as a data coordinate, I pass capital X, capital Y, and capital Z. And I pass 50 as a value to it. I'll tell you later what this 50 does. Then I call the show function as I want to display the plot. Now I execute this code and here you can see the plot. This is the contour 3D plot with x, y and z axis value as we are representing in the 3D frame. So I will show you what will happen if I remove this 50 value and execute this code. So this plot looks something like that. If we want to get the shape, we have to pass the value. If I pass 100 as a value, see what will happen. So it's look like that. It's, you can see that it had some net structure. So if I reduce this value to 50, so this contour plots look like that. Its net structure is loosely gapped, or we can say that its strides are loosely gapped. So with this we have learned to plot advanced 3D plots, and in the next module we will learn plotting data from pandas data frame.